Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. Yesterday we did some cleanup work and actually found some interesting profiler things in terms of some places in the code where we're spending more time than we should have, thanks to calling roundf instead of our own sort of code for rounding things, which we've now fixed, which is nice. I thought of something else while we were kind of on that sort of cleanup kick. I thought of something else I kind of wanted to do before we get any further, especially because we sort of started working on that camera code. And really when I look at like what sort of stuff we'll be doing next, I don't know that there's very much left to do other than sort of move into sort of regular game development mode at this point. I mean, there's always other things we can do, but you know, we're kind of out of really particularly meaningful things to do without more of a complete game running. And so one of the things that I wanted to do before we started on anything serious in terms of tuning is fix how we do our clocking, because we kind of never really went back and did anything intelligent there, and I would like to sort of do a little bit more with that. And so today I'd like to go drop back into that code and just fix a couple things I think are problematic with it. Hopefully it'll be pretty obvious what I'm talking about as we get started here. So I'm going to go ahead and jump right into that. It's day 380 here. So if you want to follow along with today's source code, day 379 is the source code to start with. I'm going to go ahead and open up the project in Trusty 4 Coder. Let's see here. I found out also that I have not been building 4 Coder with optimizations due to a build thing that was happening. So actually the 4 Coder that you have been seeing on stream this whole time is the one that's built without optimizations on. So apologies to Alan for that. Although it's still plenty fast for what we need to do. Obviously, building without optimizations makes it much slower. But anyway, let's go ahead and take a look at where we're at. So what I wanted to point out here is, oh, right, I forgot we also fixed the cutscenes. I should probably put that back the way it was. Let's go ahead and fix that. There we go. So, just recompile here. We fixed the cutscenes at the end of the last stream as well. So the thing that I wanted to talk about today is just that we've got all this stuff working here, and you know most of our stuff is okay at this point. And if we look at the profile, you know, we did a pretty good job of making sure that at least in release mode stuff is pretty reasonable. You can see here our profile in release mode is basically the only thing that we're doing, because you know the debug code is not important. That turns off completely at runtime. So really the only things that we're doing here... Wait a minute, is this even in release mode? I take it back. I think that's actually debug mode. That's debug mode. Switch over to release mode there. For what I was trying to say. So when we start the game in release mode and we take a look at the profile, we can see here that basically our top 4 functions are all exactly what we would hope, right? So here's our game, which takes no time, right? It's literally meaningless. It's the case that 95% of the time, or I guess I should say, I don't know if cumulative at this point how we did it, but I guess over 90% of the time is spent up here, and all of the rest of our game is inconsequential, which is fantastic news. The top part here, swap buffers is just waiting, right, for the GPU to wait for the vertical blank, you know, or if it had to, drawing, but I don't think we're handing enough drawing stuff for that. So basically that's just extra time that we're waiting for the frame to, the monitor. Debug collation and debug end, those are not even relevant because they turn off in the shipping version of the game. So the only thing that we really have at the moment that's costly is OpenGL render commands. And pretty much all of the time in OpenGL render commands is being spent in the driver. And so basically, if we want to optimize the game, we know that there's really only one thing we would have to start doing, and that is minimizing the number of draw calls by packing textures, either into textures arrays or a texture atlas. So we're looking really good here on our profile. Like it feels like we have absolutely nothing to worry about. And again, this is on a machine that's 10 years old at this, no, sorry, 7 years old at this point. So on a 7-year-old machine, that's what it looks like. I think we're in fantastic shape. We've done a good job keeping everything reasonable. And I'm just not concerned about anything at this point. That said, we do have one thing that becomes a problem for us and not necessarily for our customers, is that when we are in the cutscene mode and we look at the profile, everything's fine, right? We're still hitting 60 frames a second with no problem. And in fact, for the cutscenes, we're hitting it at a point where we aren't, we're waiting for the monitor most of the time anyway. If, however, we switch to the game mode, we drop. And you can see if I close the debug UI, so we're not doing anything in the debug UI, you can see that we're getting closer to 60 frames a second. But when we don't compile in release mode, it takes a lot more time. When we open the debug view, obviously it slows down more. But that's okay. We don't really care because when the debug view is open, if we have a slower frame rate, that's okay. But when we're looking at the game and playing in debug mode, we'd like it to be faster. When we look here, you can see we kind of have not a whole lot we can do about that. We've got our render volume stuff. In fact, let me pause it so it's not jumping around. You can see our render volume and render pieces stuff, which really needs the optimizer to kick in to inline the functions in order to be fast. So in debug mode, I don't know how much better that's going to get unless we just wrote a custom one, or Peephole turned the optimizer on just for that, which maybe we could consider doing. And then we've got debug collation, which again is probably not going to get appreciably faster without the optimizer turned on, although we could go look at it. And the same with debug end. OpenGL render commands is not because of debug compilation. That's the same slowness in retail compilation. It's just that function is such that we would need to do the texture packing to accelerate it, because it's the driver texture change overhead where we have to break things into batches. That's the problem there as far as we can tell. So the interesting thing about this is that just looking at it here, we would have to make the decision to spend a bunch of time optimizing this stuff in debug mode when really we don't even have a frame rate problem in release mode, and that's just not a very good idea. But we don't really have too much of a choice if we looked at that as our only option. And the reason for that is because if you look at what happens here when this little saucy gentleman is jumping around, you can see now that if we were to tune the game like this, it would be completely wrong, because it's supposed to be hopping around at the 60 frames a second rate, but instead it's hopping around half as fast because it's only running at 30 frames a second. And so that just motivates what I wanted to do today, which is 30 frames a second is a perfectly usable frame rate for development purposes, right? If all we're, maybe if we're talking about the shipping version of the game and it's an action game, maybe we're like, it's really important for us to hit 60 frames a second. That's fine, but we are, right, in our release build. So now we're talking about the debug build. What's an acceptable frame rate for the debug build? Well, 30 frames a second is plenty acceptable for the debug build. So really what we'd rather do is have the game run okay at 30 frames a second. But in order to do that, we need to know we're running at 30 frames a second. Because what's happening right now is the game always updates itself as if it was running at 60 frames a second. So if it's not running at 60 frames a second, we end up in a really bad problem, right? Because that is exactly the situation where we will get an update step that doesn't correspond to the actual speed at which things are being updated on the user's machine, right? So just taking a look at that and thinking about that a little bit, what we need to do to make that usable is and I'm also going to go ahead and set it back to, since we don't care about the cutscenes at the moment and we fixed most of the stuff we were going to fix in there already anyway, I'm going to stop. The game normally boots into cutscene. I'm going to stop that and instead just let it boot straight into the game here because this is what we're working on right now. And the cutscene runs at 60 frames a second in debug mode anyway. So when we look at what we set ourselves up as, you can see that we set our game to run up in this way where we've got game update and render. And the thing about game update and render is it's actually getting past the information that it needs to get past to do the right thing here, right? What we did is when we set that up, let me go ahead and get that here. When we set it up, we have this game input structure here that gets passed to it, and it says right here DT for frame. And actually, everything in our game update and render is actually using that. And for example, I believe if we were to set that DT for frame to 0, the game would just stop updating, right? We'd be looking at the opening thing and nothing would move, right? So our game already properly respects a variable time step. We can set it to whatever we want. We can make the game run incredibly quickly by setting the time step to an artificially huge value. You can see it happening here, right? We can go and set it to some more reasonable but still faster value, and you can see everything looks like it's running on speed. So, you know, we did the work of having a variable frame rate, but the reason we're not getting that variable frame rate is just because that value is getting passed arbitrarily. So if we go back to the Win32 layer, what you can see here is the DT for frame, what it's getting is the target seconds per frame. And the target seconds per frame is always set to the same thing. It's whatever we wanted the update frame rate to be in an ideal world. So since we wanted that to be the monitor refresh rate, so if you had a 60 frame per second monitor, it's 60. If you have a 120, it's 120, whatever, right? Since we kind of just took that at face value, it means that if we ever miss our frame rate, we're just woefully wrong, right? And so if we take a look at what's going on with this code here, we can see that it never bothers to look as to whether or not it hit its frame rate. It just always blindly assumes that the target seconds per frame is the target seconds per frame, is how many you actually got, right? So if instead we were to set the target seconds per frame separately, right? So if I instead said, well, okay, let's look at where we're setting game update hertz, right? And here's the monitor refresh rate or whatever it is. If instead of that, I magically just knew I was only going to get 30 frames a second, right? Because remember, here's what this looks like. If I run this, here's what it looks like, right? And it's kind of sluggish to move around. It's not nice like the 30 frames, the 60 frames a second version in terms of speed. If I instead said, well, okay, what if I had said the game update target seconds per frame was going to be twice what you thought it should be? So it will be 30 frames a second is what you think the target should be. Well, now when I play the game, hey, look, it feels exactly like the 60 frames a second version. And yeah, it might not be as smooth of a look because we're not getting as many frames as we should be getting if we were getting 60 frames a second. The game plays properly, right? And that's what we care about here, is making sure that the game always plays properly. So if the player does have a machine, which in all cases they will, because, you know, like I said, this is a machine that even this 7-year-old machine with a really old graphics card is fine for this game at 60 frames a second in release mode. But in debug mode, what we could think of that as being is like, okay, a user has a really slow machine, right? In that case, if they get 30 frames a second, that's still perfectly playable. You could totally play the game like this. And so we don't want them to like basically not be able to play the game just because we don't set the timing update right. So in both cases, both because we want our debug build to play properly and feel correct even though it's running at half the frame rate of the release mode version, but also because maybe sometimes people will play this game on a really old, really slow machine and need to have it run at only 30 frames a second for them. What we need to do here is figure out a way to set the target seconds per frame adaptively, so that as we see that we're not making our frame rate budget, we bump the target seconds per frame back up, right? And this is a really tricky thing to do. It's actually very difficult to get right, and we'll probably have to play with it a bit. At the moment, we don't have to do an industrial strength version. We can do something slightly not all that great. And in some senses, something that's not all that great might actually be okay in a lot of cases, because again, for this particular game, we know that most of the time on most machines, it will be able to hit 60 frames a second and maintain that for the majority of the frames. So in our particular case, we aren't really that worried about having to have monitor frame rate fallbacks be all that awesome, but you never do know. So what I want to do is start by taking a look at this, how we've structured it here. So what you can see is we actually have some interesting baked-in assumptions here. You can see this samples per second, samples per buffer, second buffer size stuff here. This stuff is pretty much all, I think, going to be okay because nothing here depends on the target seconds per frame. The sound output is sort of run on a separate clock, and I don't think we have to worry too much about it. So really what we're looking at is the people who look at target seconds per frame. And what you can see here is we don't have a whole lot here to worry about. Basically, we're looking at a couple things in sound anticipation here. They are just try to estimate where the sound cursor will be. And then we also have this sort of weighting, this frame rate weighting stuff here that we don't turn on anymore, which is just to allow the game to go to sleep occasionally. And I don't think we need that anymore because for the most part, swap buffers will take care of that for us. So I think this can stay safely off probably, but we'll see about that as well. And so then what we really need to know here is just for the one real use of target seconds per frame that we care about here, which is DT per frame, how can we adjust what we expect our target seconds per frame to be based on, you know, what we see happening in the game? So the first thing I want to do is I want to take this target seconds per frame and I want to move it down into the game loop. So what I'm going to do here is basically say, like, okay, what if I were to set this down here? Does that create any problems, right? And no, it doesn't, so that's good. So if I were to set targets seconds per frame on every frame, what I could do is I could adjust this multiplier here, which is how many frames of the monitor's refresh rate we think it will take us in order to safely finish the work that we need to do before that next VBlank, you know, that next monitor refresh rolls around. And so essentially what I want to do is I want to introduce a value here, which is like, you know, expected frames per update, and I'm going to set that to 1. And I'm going to put expected frames per update here. And what I need to do now is I just need to be able to twiddle that value. I guess we don't have one of those yet. There we go. I just need to twiddle that value to be, you know, 1, 2, 3, hopefully never higher than 3, because 3 is already down to, what, 20 frames a second? 20 frames a second, I think, would be pretty unhappy as a play rate for a action game. You know, an action game at 30 frames a second is pretty much your bottom that you'd want to be at. A non-action game, not so important, especially not one that's, if you're in 3D, sometimes it can make a difference because the eye can be frame rate sensitive there. But for a 2D top-down game, you know, 20 frames a second is probably fine if it's a strategy game. But for an action game like this one, if that multiplier went up to 3 on a 60 hertz monitor, not so great. Now, on the other hand, let's say it's a 120 hertz monitor, which does exist. If you had a really high frequency monitor, then 3 is not such a big deal, right? Weighting 3 120 hertz blanks is not an unfortunate frame rate. So, you know, you could imagine different monitors sort of giving us different flexibility in terms of how many frames we can wait. So what we need to do now is have some way of figuring out what we think the number of frames that has elapsed is every time through the loop, right? Like, how long did it take us to do the processing that we need to do? Like, what are we actually seeing as a frame rate? And so what I want to do is to introduce an actual just straight up time here. And I don't know if we've got, yeah, we've got get wall clock. So we have the ability to get a wall clock here. And what I want to do is just have a wall clock that times our frame that allows us to adjust. Now, I don't know if we're using that anywhere already. We might be. So you can see us timing some things here, in fact, right? Yeah, you can see us using this with the wall clock bit here. Yeah, so we actually have quite a bit of information, and we have like an end counter here that gets the wall clock. We subtract that from last counter and an end counter. So if we take a look at what's happening right here, this bit of code is already giving us the information we need. This win32 get seconds elapsed last counter end counter, right? This is our measured seconds per frame. That right there. And so with that measured seconds per frame, we actually have the ability to set what, if we took a look at what that was, we actually have the ability to figure out how many monitor refreshes we think went by, right? So for example, if I just pop over to the Blackboard for a minute, here on day 380, so what I know is that my target seconds per frame, so whatever, I don't know, seconds per frame, or I guess maybe I'll talk about seconds target, right? So my target seconds per frame is going to be 1 over the refresh rate of the monitor, right? So this is the monitor hertz. So this is HZ. So my target seconds per frame is going to be 1 over the monitor hertz in the best case, right? Another way to say that is the minimum time. So in fact, probably I shouldn't say target. Maybe what I should call this is the minimum amount of time. So in other words, if we want to be synced to the monitor refresh, which we do, the minimum refresh rate for the minimum amount of time we could possibly take in a frame is 1 over the refresh rate. And the reason for that is that we don't want tearing, right? I know some players prefer tearing, but not in a 2D game like this. I sure hope they don't. So the minimum amount of time that any sensible thing would happen here is 1 over the monitor refresh rate. And so what we want to do is we want to set our frame target to, you know, some other value over the monitor refresh rate here, right? This is what we're trying to figure out so that we know how many frames to expect to have to wait to be able to display the results, right? So what we're interested in knowing now is we have a seconds elapsed. We have how many we took for a given frame, right? And so what we want to know is how many of these occurred in one of these, right? So we want to know the, you know, what is the multiplier on the minimum seconds, right? In order to produce the seconds elapsed. And that will give us this x that we want here, right? Another way to look at it would be we want to know if we wanted to set our target frame rate to what we were observing in practice, right? Because this is how much time we see going by. We know this is the equation for how much time we will expect to go by. How about we solve this equation? So the view that we see, however many seconds we see, we've got the monitor refresh rate here with our x on top. So that seconds elapsed times the monitor refresh, right, equals our x, if that makes sense, if I did that math correctly. So our measured time plus times our monitor hertz is going to be what we think our x value should be on top there, right? That's just what that looks like. And so let's see if that makes any sense, what I just said. So let's say 1/60th of a second went by, right? And I'm going to multiply by the monitor refresh rate, which is 60, and I'm going to get an x. Well, the x value is 1, which is exactly what I would have expected, right? On the other hand, let's say that quite a bit more time goes by than that, right? Let's say that 1/20th of a second goes by, quite a bit more. And I multiply that by 60, and then what's my x? Well, in this case, right, all right, I cross these here, I would get a 3 here to divide out. And that makes my x equal to 3, which again is exactly what I want, because 3 60 frame a second frames is 1/20th of a second. So what I want to do here is say something like, well, okay, I've got a target seconds per frame here, right? This is my exact target seconds per frame, I guess you might say. That's going to be that measured seconds per frame times the monitor refresh rate, right? Exactly like we said there. But the problem is this is now going to give me back a floating point number. And I can't wait a floating point number of frames. Now, if we had G-Sync or something, or whatever the AMD equivalent is of these saucy gentlemen that monitors that can switch at an arbitrary frame rate, then maybe that's fine and we just set it to whatever. But even in that case, I don't really want it to be variable. So even if we were going to set it to some thing, I still want something smarter than this, so we could talk about that a little bit later. But in the case of a normal monitor, which most people have, or a TV set, it can't flip at an arbitrary frame rate. So we need to now round this, right? And the question is, how are we going to round it? Well, if we strictly round it up, we're going to get a problem of overestimating the frame time, right? Because if you think about what happens, 1/60th of a second is what we would get if we measured it perfectly, with no overhead, no jitter, no nothing. But we're never going to get that exact value back when we measure the clock. We're going to get something if, here's the graph of times, right? And I've got, 0 seconds down here and 1 second here, and so somewhere in here we've got, 1/60th of a second. We're not going to come back right here. We're going to jitter around there. Even if we're hitting 60 frames a second, the time that we receive measurement-wise is going to jitter around the 60 frames a second quite a bit. And you can see this happening even if we just run the game. You can see this happening up here, right? So you can see right here that we're just jittering around. And even in the case where we build in release mode, which I'll show you here. So let me switch us to release mode there. Even in the case where we build in release mode, what you can see is that it's not always 16.66 milliseconds, which is what we would want it to be. Instead, it's like jumping all around, right? And that's just because of whenever our thread got, the clock back, and what was the latency on the clock measurement, and how long did it take to get back out of the driver after the VBlank hit, and all this other stuff. It's just not going to be a precise value. So certainly any human can look at that and say that it's 16.66. Okay, we're getting 60 frames a second. Good. Keep trying to hit 60 frames a second. A computer that just does the divide, it doesn't know that. It doesn't know how to look at a value and go, oh, it's basically 60 frames a second, right? So what we have to do is put a little bit of logic on here to try and say, well, okay, what is the region around 60 frames a second at which we still feel fairly confident that we are hitting 60 frames a second, not missing 60 frames a second? And the answer there is, well, if we were to miss 60 frames a second, then we know we should shoot up to more like 20 or some other frames per second that would be significantly higher than 16 milliseconds, right? We would expect to kind of have that a bigger jump there. So for the most part, it should be safe for us to go, okay, let's take a look at what the value is, and if it's within a reasonable region around a 60th of a second, that would be fine. Okay? So here's what I think we want to do. What I think we want to do is say, well, okay, let's round this value. So let's take a look at the value that we're going to get for expected frame expected frames per update. And I'm going to call this new expected frames per update. And what I'm going to do is I'm going to round this value that we got back. And so this is going to give me a rounded version of the expected frames per update. And that will be something that we could just use directly, right? If I wanted to, and it'll have all the drawbacks that I just said, if I take expected frames per update and just set new expected frames per update to it, that should work just fine for certain circumstances. So if I go ahead and run here, you can see that we're not getting any interference in our 60 frames a second version, right? So that's all working just fine there. Right? Looks reasonable. And the other thing that we probably want to do is show what the DT per frame is there as well, so that we can. I don't know why we're still printing those out, but we probably want to output that value as well, just the DT per frame, so we can see what it's going to be. I don't remember how to use our debug system because we use it so infrequently, but let's just pretend that we can. Maybe I'll put it here. I guess I want it kind of below. Well, no, you know what? We can do expected frames per update. Debug U32 expected frames per update. I don't know if that'll work, but let's just find out if it does. Apparently that's not. What do we have up here? Oh, so I guess we can just say debug value and it will automatically determine the type. It's just Boolean, since they wanted to be specified true or false, get specified separately. All right. So I think that's all we need to do to show debug value. Again, I don't really remember, but let's find out. There we go. That should probably be just under platform. There we go. And so it's only expecting 1 frame per update, which is exactly what we would want. I don't know if we can slow this thing down enough to make it go. Okay, so you can actually see it happening now. And it's a little bit weird. I'm not sure what the difference is here. But if we sort of look between frames, you can see that the OpenGL render commands is taking drastically different amounts of time in these two cases. You can see it like. And it's like we must just be on the edge of missing. So you can see us flip from 1 expected frame to 2. So you can 16 to 30. You can see us like hopping between those two. And so you can even kind of see already happening what I was sort of saying we need to why things need to be a little bit smarter. But basically, let me go ahead and return that on. But basically, this works just fine in any circumstance where we're hitting the frame rate okay. And so I suspect we could also go here and turn this to debug, which will reduce the frame rate. There we go. And I would imagine that we could look at this and see that now it's picking 2 frames for update as well, right? Now, what I don't know, and I guess this might just be because of oscillation, is I don't know why we're getting an in-between millisecond value here. Because as far as I know, if we told it to wait for the vertical refresh, right, if it's a 60 frames a second monitor, then the frame rates should be like, it should be 16 milliseconds. I mean, just hear me out here. I'll do it on a calculator just to make sure I'm not crazy. But you know, if we were to look at what we expect, if we're going to go 1/60th of a second, that's 16.66 milliseconds, which is what we were observing. If instead I was to change it to 2 vertical refreshes, that's 33.33 milliseconds. And instead, we're seeing something like halfway in between those two, right? We're seeing like 24 or something like this as the value. And I don't know how, if we're asking for a vertical refresh timed flip, I don't really know how that's happening. So I'm just going to double check. I don't know what we're setting the what we're asking the graphics API to do there. So in swap buffers, I need to take a look, because what swap buffers is going to do is swap buffers, which I don't know where it is. Where is swap buffers? Is that in the OpenGL layer or something? Oh, right. It's actually just called... I was thinking it should be GL swap buffers, but it's not. It's a GDI call. Anyway, the swap buffers call is going to take up to the next v-blank if that's what we told it to do. But I don't remember what we told it to do. Wiggle swap interval is the call that controls what we want to do. And you can see in this case, we were passing a 1 there, which means we want to flip on every monitor refresh, right? And so if we take a look at what we get there, I don't think it should... There should be some documentation for this somewhere. Can I have spec, please? Here it is. So as far as I know, right, it should be the minimum number of video frames that are displayed before a buffer swap will occur. All right. So I guess I don't know whether it's going to swap as soon as it can after that, or what. Because I had thought that there was a -1 value that you pass if you want it to do a swap like on the vertical refresh, or if you missed the vertical refresh as soon as you can thereafter. I thought was it was basically like, hit the sync if you can. If you can't, then tear, right? And I know this was an extension that was kind of added a little bit later. But I was pretty sure that that was not something that was actually... that you said if we didn't specify it, that would not happen. But I don't know. That's definitely not what I'm seeing, right? Because as far as I can tell, the frame rate in this case is very consistent, and it's at 24 frames a second, even though we very specifically told it not to do that. Now what I'm going to do is I'm going to crank this up to 2, which should enforce a frame rate of 30 frames a second, just to see what happens. And so what you can see here is that, again, not 30 frames a second. And I feel like, I don't know, I feel like we're explicitly asking for that and somehow not getting it. Let me see here what happens in that particular call to wiggle swap buffers there. And just see, I'm sorry, wiggle swap interval. You know, I guess what I would say is, where are we getting this from? You know, I don't know that this is where we would want to be getting that from. Because maybe we can't, maybe we have to ask for it. Maybe it's not actually working. Like maybe we have to ask for it on this particular context, because that's the other context up there that we were asking for it on. So I don't know, maybe that has something to do with it. I don't think so, but I don't know. It doesn't seem to be paying attention to us. Yeah, so I don't know. But what I can say is that, you know, from playing with this value, it sure doesn't seem to be having any effect, because I should be able to slow this thing down tremendously by forcing it to wait many frames before flipping, and it definitely isn't doing that, right? It's not ever waiting any more than 1 frame. So I would be interested to see why that is. Let's take a look and see if we can gain any insight into what's happening there, because that's definitely very unusual, at least as far as I can tell, unless there's something stupid that I'm doing that I'm just forgetting about that would cause us to be having that problem. So I'm going to just jump to this point in the code, and I'm going to see if we get that function at all. We do, right? And then we're calling it here. And you know, I don't know. We'll have to look at what its return value is. It returned 1. I don't know what it's supposed to return, but presumably 1 means it succeeded. And you can see very clearly here it says an interval set to a value of 2 means that the color buffers will be swapped at most every other video frame. So in theory, that is exactly what that should have done, right? At least as far as I know. So I wondered if this is actually not quite working. One thing that could be the case, and I don't know, is I wonder to what extent this is because of the sort of not proper thing we were doing due to streaming. So, for example, the handmade streaming thing here, right? We were kind of using this illegally, and I do wonder to what extent that is messing things up. If I turn off handmade streaming, which means you won't be able to see the OpenGL window, I think, but I want to see if that makes the wiggle swap interval work properly. So it definitely makes the wiggle swap interval work more properly. It's still not quite perfect. It's a little bit wonky. So I'm not really sure what's going on there, but at least looks a little bit better. Let me go ahead and try playing with that wiggle swap interval there. So I'm going to set it to 1 now again, and I'm going to see what happens when we run the game. So interestingly enough, the game does not properly use setting it to 1. If I set it to 2, so if I set it to 2 with that double buffering flag properly set, which I think means the streaming won't quite work, then it does at least mostly tend to hit 30 frames a second. But it's definitely an unusual pattern here, and it seems to me like the measured frame rate is quite wonky. So, for example, I'm just looking at it, and I see that OpenGL render commands takes twice the time on some frames than on others. And I can only assume that has something to do with waiting to flip, but I really don't know. So again, it's pretty hard to see. Let me just verify that you can't see, right? If I turn off the handmade streaming, you can't see it, right? But what's weird about that is even if I turn it off, it's still not quite right, and I don't know why, right? I have no idea what is actually going on there. Why wiggle swap interval is not giving us proper v-blanking. Right? And it could just be, I don't know, it could have something to do with the fact that OBS is running. It could have something to do with the fact that, you know, OpenGL is poorly supported on Windows. I really couldn't tell you. But what I can say for sure is that it's not behaving in any way that we can really reliably use. Because I know this monitor is not capable of anything other than 60 frames a second, I don't think, unless that's wrong. And I'm pretty sure that's not wrong because, you know, well, I mean, here's a question for us all. I guess I could check to see what the refresh rate of this monitor actually is. And I don't know that I can really look at that on here. Maybe I can. Let me take a look at what this Catalyst Control Center thinks is going on. So it certainly thinks that the refresh rate is 60 frames a second. That's what it thinks. It also, if I'm not mistaken, seems to be drawing off the bottom of the screen, and I can't make this window bigger. So there's that, which always is good. I don't know how that happens, but that's great. So I don't know. Looking at this, if the graphics card thinks that the monitor is 60 frames a second, then I feel like that's all we really need to know, because the graphics card itself, if it doesn't think it's outputting at 120 hertz, should not be able to hit 25 milliseconds as a frame rate. It just shouldn't be happening. So I really have no idea what OpenGL is thinking at this point. I don't have even the slightest clue. I would like to know, but I really just don't. I don't think there's anything in here that will help me get any further down that road. I don't know why there's two of these either, because I think there's only one graphics card in this machine, but maybe that's not true. I don't know. Well, so I guess I'm not sure exactly what we can do here. I mean, one option we have is just ditching that concept altogether and saying, well, if we can't get reliable weighting back from the graphics card, which I guess we just can't, and let me make sure I turn streaming back on. Yeah, there we go. You know, maybe we just try to, I don't know, you know, maybe we just try to say, well, we'll set the target seconds per frame to whatever we measure as our sort of reasonable, stable, whatever our stable value expectation is for the seconds per frame. I mean, it's not a horrible thing. It's just it leads to a sort of varying frame rate, which has like micro jitter that I really don't want. And so I want the game to have a predictable frame rate and to stick at 60 and update at 60 all the time. And so I don't really know what to do here in that classic way that Windows doesn't like to care about things like that have real-time implications. It kind of leaves us with not a lot of options here because I don't really know what we could do to force the update to obey us and actually only update on the monitor refresh, unless, again, like maybe I'm just forgetting something that we did that causes that to not work properly, or something like this, but I don't know. So looking at this here where we've got the refresh rate, and where I'm setting this every frame by doing just an integer clock. Let me grab that there. Maybe for now we just use a target seconds per frame that's carried over from the previous one. I don't know. I mean, that would look like this, where down here we just say whatever we got for the last frame time, just use that, right? And so that would be exact target seconds per frame. And then we would just say, like, all right, if you're running at 25 frames a second, sort of, oops, that didn't work so well. Then off you go. Did I do that right? Exact target seconds per frame equals measured seconds per frame times monitor. Oh, this is frames per update. Go. I want measured seconds per frame. There you go. So there is, I guess, what would happen if we just used the clock from the previous frame. And again, the reason that I don't like what I'm seeing on the screen right now at all is look at how much jitter there is in that value, right? It's nuts. um, how much jitter I'm seeing. I come here, it's 24. I come, here it's 25, 24.35, 25.76. There's just a tremendous amount of jitter. Like, what's that frame? 33.74. I don't even know what's going on there. And so it's really just awful in terms of the stability, and you can feel that in the gameplay, right? I can feel that as I'm driving around. I can feel exactly that. It just feels a little micro jittery, right? And so I hate that, and I don't want that to be the case. But again, it doesn't seem like ATI and Windows are giving me any options here, at least not on this graphics card on this particular setup, for actually making it work. So we may just have to live with that for now, at least on this machine, and go from there. Hopefully on other machines it would be a lot more stable anyway if it was coming back at a reasonable 33 value all the time. That would probably be fine. But again, I really just don't know why we're observing that result, because it seems like it's basically just not obeying wiggle swap interval at all. It's just ignoring it completely and be like, well, thank you for taking the time to tell me, but I really just don't care about what you want to have be the swap interval. Now, I guess one thing I should check is sometimes there's a swap interval override on these things. And I guess I don't know if that's the case. Sometimes there's like a graphics, like 3D options or whatever. And I don't even want to know what all of this stuff is. How can I get some 3D settings here, people? I do not know what any of this stuff is. I don't want any of this. I don't care about video at all. I like the fact that apparently, like, it has hung itself just trying to display the video at all. That was good. Well, all right. Not going great, if I have to be honest. Not having a great experience here with the drivers. Not loving it is not a thing that I'm doing at the moment. I don't know how to get the Catalyst Control Center to give me here, let's try switching it to basic. So there were 3D settings. How do I get those settings? Like, we saw them, but we cannot set them. I just don't even know sometimes. It's so ridiculous. Like, how is it possible? Is it down here, like in the place that I can't get to because it won't show me what that, like what those values actually are? I wonder if WinSpy lets me snoop that. Like, I don't suppose I can just force it to be bigger. Yeah, I can't edit things in WinSpy, unfortunately. It would be nice if you could just force it to send a, because you could send a WM size message to it. I don't know. So I don't even know how to look to see whether it's doing that. We could again go back to the basic one and see if the basic one has it. Let's see. Is it just me, or like I literally just have no idea what's going on. Like, I have no idea what is supposed to be happening here. I don't even understand how you ship something like this. It makes no sense to me. It just doesn't seem plausible that you could end up in a circumstance where, like, all this is a thing that has to have some buttons on it. How is it so broken as this? I have no idea. Anyway, if it was possible to see, we would look and see, because many times the graphics driver has the ability to override settings like frame rate cap like that. So, you know, if players don't want the game to run vertical sync and they prefer the tearing, they can go in and set that. And so I would have liked to have checked to see whether the driver was set to ignore frame rate limiting like that, which I don't know. I don't suspect it is, and the reason for that is that if we run below the monitor refresh, it does seem to be waiting. But I have no idea. Absolutely none. So I guess we gotta leave it like it is for now. It's better than nothing, but it's not great. Because I really don't like that micro jitter. That little sort of wobble in the frame rate is like something you can feel. I feel it in a lot of games that do this sort of thing, and I don't like it. And I would much rather it be locked at 60 frames a second much more cleanly than it is at the moment. But, oh well. So here we are playing the game though, and at least, you know, it's even, I can even open this up, and the game still plays properly even when we drop considerably frame rate by like doing a lot of profiling stuff that tanks the frame rate. Like you can see that frame rate is now even less than 30 frames a second. But the game is still playable at this frame rate because as I'm moving it around, you can kind of see it maintains the speed that it should have. So all the entities are updating at the correct rate, which is all we really need for now. It's really disappointing that the graphics driver is not willing to play reasonably with those settings. But that's okay. You know, we'll just deal with it for now and be done with it. All right. Well, that's that. Here is an example of us running at a very slow frame rate. And again, you can kind of see, hopefully, that it's still playable in terms of the correct speeds. So things are still moving at the correct speeds. So at least that's better than nothing, right? All right. Oh, well, close that up. So that's all I really wanted to do. I just wanted something that would allow us to tune the game properly. And so that we wouldn't be in this situation where every time we were in debug mode, the tuning would be off and the speed of all the things on the screen would be wrong. I would like to do it better than what was just done there. I don't like that at all, but I don't really think there's a whole lot I can do about it at this point. That's just the reality of Windows sometimes. So, you know, it's fine. It's not the worst thing in the world. So it's okay. And, you know, the other thing I guess I would say is, at this point, you know, At this point, we can save that sort of thing for later, I suppose. It really just matters that the game plays at the frame rate that we think it should play at. When we tune the speeds, they are roughly the correct speeds. So as we're making stuff in the game, like the speed of the hopping or whatever else, it doesn't have to get drastically redone later when we have a correct frame rate. So if it's, as long as it's close, which I think it is now, and it just has some jitter in it, then I suppose that's okay. I suppose. So anyway, let's get back then to take a look at what's going on with the camera here, because I think that's really all that we wanted to finish up. I don't know. I guess there's one other rendering thing we wanted to do, which is as we go downstairs, we want to be able to eventually switch to. We gotta do work on our hopping too. At this point, I kind of want to play the game because it's explorable, but we have such poor hopping code. He always thinks that the closest thing is that sort of those things on the side there and there. So it's really hard to go downstairs, and it should be nice and easy to go downstairs. So we kind of want to work on that hopping code. But anyway, once I hop down here, this is the other thing that we wanted to look at, and we could start looking at that soon as well, which is the camera is now technically operating properly. Like, this is probably roughly what should be happening. The problem is we're not fading out that upper level, right? Because we're actually probably at the right place camera-wise to play the floor that's below us, but we can't see the floor that's below us because of all this stuff that's in our face right now, right? So one thing that's, maybe let's start looking at that, because, I don't know, I'm in a grumpy mood because ATI was, basically, peed on our cake. It just, basically just took a big old poop on our ice cream cake. We now have got Fudgy the Whale, literally. We've got ATI presents Fudgy the Whale poop cake for our game. What we want to do here is go like, okay, what can we do to make this problem go away, right? We want something that's going to be reasonable, where we can have something that's, as you have elements that are in front of the camera that are preventing you from seeing what you're trying to play with, or what you're trying to see for the level, we want some way of taking care of this. And you remember us doing this manually back when we had everything in 2D sorting. What we would do is we'd place things into sheets, essentially, and we'd alpha blend out those sheets. So the question now is, can we do something a little bit fancier than this now that we have 3D at our disposal? Maybe make it so that that is automatic. And so like the fog, if you remember, we had to do that manually before. And now the question is, can we do the fog, that same sort of tricks we did with the fog, where all the fogging happens in the shader automatically now? Can we also do that with this sort of notion of removing things that are close to the camera? And so what I want to point out, just first of all, is that if we go to the code that's setting the camera for the game, which is in world mode.cpp, we're setting a near clip plane, right? And what we could do, obviously, is if we move this near clip plane out, eventually if we moved it out far enough, right, it would clip away the stuff that was in front of us, right? It would just go away. I think that may have been a little bit too much. I think that, yeah, there. Well, I clipped away 2 levels, right? That near clip plane is actually just a value that we can sort of scale, right? And as we move the near clip plane out far enough, we get into a place where the things that we didn't want to see anymore have gone away. So the question at that point naturally becomes, well, if we can do that, if we can clip it away using something automated like this, might it not be possible to just, use that to automatically clip things out and alpha fade them in, right? And there's some issues associated with this. It's not necessarily going to be trivial. What I want to show you, the reason I'm hopping up on here, is I want to show you the main artifact problem that we will have. And we have to kind of think about how we might want to solve this problem. But what you can see here is that as I hop up and down on this and things slowly clip in, what you can see is that the faces peel away gradually, right? And so that would be our main issue that we'd have to contend with as we sort of hop in on these things, right? You see how they're kind of clipping out like that? You see how that's happening there? Right? And it's kind of interesting effect, actually. To be completely honest, it almost makes me wonder if we want to kind of embrace it a little bit. I was kind of going to say maybe we should yeah, I was gonna say, like, how do we work around it? I mean, I don't know what to say about that at this point. It kind of it feels almost like a good thing. I don't know what to make of that. But as a result of that, of seeing that now, I'm always kind of wondering what would happen here if we were to just you know, if we were to kind of just alpha peel that stuff away, maybe that would be kind of cool. I was thinking that we wanted to do a more sensible thing. I don't know, that's really kind of cool. I don't know, let's play with that. I'm kind of interested in this. So let's suppose that we took our near clip plane in the shader and we colored the values that were near the near clip plane with a different like fogging system or something, right? I'm just thinking of what that would look like. So if I went to OpenGL, right, and I've got my renderer here for my fragment shader, you can see here that we've got this fog amount situation here, right? And the fog amount is coming from the vertex shader, and it's being computed by taking that inner product with the fog direction, and it's producing a fog distance, and then we're mapping, you know, that fog distance in here to produce this fog amount. And so what I'm wondering is, you know, could we just do exactly the same thing with a fade amount and fade the alpha out in the same way, right? So I guess, you know, the thing that I'm wondering is, we're already passing out a frag color. The frag color has an alpha. If I wanted to modulate that alpha by something that was coming from the shader, I don't know, what would that look like? So here what I could do is say, oh yeah, the alpha amount in this case is going to be a clamp. We already know the fog distance, and so that fog distance we could also use the nearing far clip plane to know, well, the near clip plane is going to start clipping out at 5 at the moment is what I set it to here. You know, so let's say that it starts at 5 and goes to 6 or something like that, and we'll just modulate the alpha by that value. So we'll just say, all right, the frag colors output alpha is going to be multiplied by that alpha amount. Again, I'm kind of just making this up as I go along. I'm not even sure what I'm doing here. I'm just playing around with a stupid idea and seeing what happens there. So that may be a little aggressive, or maybe not. I don't know. But it's kind of neat. It goes a little too far. So I think we want it to be probably tighter than that. You know, maybe it's more like 5.25, so it's a pretty tight clip there, like so. And honestly, the biggest problem with that at the moment is just because we're using alpha to coverage and we only have 8 steps of alpha, that's mostly what we're getting as a downside there. So unfortunately, it's a little hard to know what that would look like without the alpha to coverage. So I don't know what to make of that exactly. We kind of want to try one. It would be nice if we had a card that could do more samples per pixel, like a 16x or more multi-sampling, because that would really be the best thing for us. So thinking this through a little bit more, I'm trying to decide like what I really want to do here. I kind of want to play around with this a little bit more, but I'm not sure what direction I want to go with it. I may still want to have it be something where, like I may still want to have it be something that does the fade in and out kind of more on an object basis. I should probably think out loud so everyone else can know where I'm, what I'm thinking of in my mind. So let me tell you what I was going to do originally before I saw that thing. That weird sort of peeling effect. And maybe, oops, I guess I already wrote that. So let me just say what I was going to do first, and then I'll talk about sort of why I'm now like rethinking it and what maybe I could do as something that's more fun than what I was planning originally. So what I was thinking of doing originally was saying, well, okay, so, I've got this circumstance where, I've got these blocks on the top level, and then I've got blocks on the bottom level, right? And, I know that I can make a clipping plane here and say, well, everything that's below it is what I'm viewing, right? Here's the eye is viewing downward here. So these are the things that we're looking at, the heroes down here. And this is in the way, and I know that I can use the z-value of the things on the screen to tell me whether you're above or below this line. So what I was thinking might be interesting to do is just draw everything twice, right? Draw everything one time with the z-buffer set to pass things that are on this side of it, right? So that I get just the stuff in this buffer. And then another one that's set to pass things that are only on the other side of it, so I get a buffer with just these. And then I would alpha this buffer on top of this buffer with a specific alpha based on, maybe the per pixel depth, right? Just remember the depth values and use the per pixel depth for that. But now I'm thinking maybe we want something fancier. Maybe we want something fancier than that. And I don't really know. It seems like maybe we do want something fancier than that. And maybe we want to do some kind of a per pixel fade out like we were doing there where there's multiple layers. So how about this? Let's throw this out there as a possibility, and we'll just run it up the flagpole and see who salutes it. So what if we did something that was sort of like a depth peel? It is sometimes called. So what if we rendered the the whole thing once? So we just rendered the screen. And so I'm talking about, I'm talking about something where maybe we just say like, okay, let's not do this. And we just render the screen this way. So we render this view. And then maybe what we do is we say, well, also after the depth, after we do that first render, so now we have one screen that's like what we can see. We save the color, but we have the color buffer and the depth buffer from that. So we save this. So we know at every location, we know what the Z value is, right? So we know what this is. And the next thing we do is we render again, but we keep this depth buffer in place and say we only want to render things that are behind, like they've got to be lower than this value. So we like pipe the depth buffer in here. We also render a depth buffer here for depth comparison purposes, but we also compare against the depth buffer from the previous one as sort of a like, don't draw anything that's above this thing. So this would give us sort of the next layer back from everything that we're seeing. You know what I mean? And then what we could do is we could fade out that top layer based on the Z values of the pixels that were in it to whatever the next Z value down was. Does that make any sense? It's a way of sort of getting that sorting without needing to use multi-sampling. Just a thought. And now that I'm saying it to myself, I'm also wondering, I'm kind of wondering to myself, why don't people just do that instead of alpha to coverage? I mean, in theory, couldn't we turn off multi-sampling altogether and just do 2 depth peels, and that would be it? Because it kind of seems like that would be it, doesn't it? I mean, correct me if I'm wrong, and again, I'm just thinking out loud here, because it's not what I was originally planning to do today at all. Not that I really make a plan, but what I had in my head when I walked in to the office, I'm just thinking to myself, like, well, right now we're using multi-sample with alpha to coverage, but do we really need that? Because if I have a sprite, and the only thing that I'm trying to do here is take these values that, that are like marginal and blend it with what's behind them, why couldn't I just do 2 passes where I peel away one depth layer and then just use the 2 closest step layers and blend together those in a shader that actually does a perfect blend, not an 8-step blend that yields kind of ugly shadows like that junk right there. That I kind of had said before, if we really want to do that right, we got to do something better than that just to begin with. It really sounds logical to me, and I must be missing something because I'm not sure why everyone wouldn't just do that. All right, well, I have no idea. I really don't know why you wouldn't do that. It seems like what you would do. It seems like it just kind of works. And furthermore, it seems like you could do that as many times as you wanted. I think I'm just going to do that. It's not really a great day for it because I have 40 minutes left and there's zero chance that something that complicated with the GPU in OpenGL is going to work in 40 minutes. It's just not going to happen. But I'm going to start that because I feel like that's just better than what I'm doing. I feel like that's better than alpha to coverage. I feel like that lets me fade stuff in. I feel like it's just a win all around, and there's not much of a downside to it. You might have to make a special concession for translucent particles, but I think you could just have the shader be aware that they were translucent particles and always peel back to the backmost translucent particle in your set or something and be fine. So I think you just want to do this. I really think you do. And we're already attaching a depth buffer, so we already have the ability to sample from the depth buffer. If I were to turn off the multi-sampling and just use the regular drawing, which we already have the ability to do, right? I mean, if I'm not mistaken, if we just set this to, not be multi-sampled, then you would, okay. Why are we calling, I thought the whole point was we didn't call GL, oh. We're still calling text image multi-sample for the depth component here. Let's try that one more time. So if I want to here, I can just call GL text image 2D, presumably. Depth, blah, blah, blah. I'm not sure what the format for this should be. I probably just... Right, this needs to be like GL depth or something. This needs to be a depth component. We're not actually specifying it, so these values are meaningless. But let me just check to see what GL text image 2D wants for a depth. So the internal format we know, so we just want this. So it's probably luminance is probably what it would be. Let me double check that in docs.gl. Okay. So in here it looks like it's just in the modern versions of OpenGL, it just is GL red. Like if it's a one component thing, then it's just GL red, right? And we don't care about this. This is the only part that we care about. So let me just check to see if I can generate one that's not multi-sampled, and we'll see. And that's just getting this one to work properly. So all right, so we've got the slot type with, what are the parameters to this that I actually care about? Let me just make sure. The target, again, should be just whatever the slot is, so that should just work. Yeah, I don't think there's anything weird going on there. This should be supported. So I think yeah, GL depth component 32, well, 32F, or GL depth component 24. I don't see 32 in there as one of the default ones, so maybe we should back off of that. Maybe I should ask for something more like that. We got the width and the height, the border value, the format, which is fine. I assume this is okay. So I don't know why it's thinking this is an invalid operation. It sure doesn't seem like an invalid operation. But unfortunately, it won't tell us anything more specific than that. So we don't know what it actually does not like about that call. I assume it has something to do with this specification, but I don't actually know that that's the case. So it's hard to sort of guess. It's one of the downsides of OpenGL is the error reporting on a lot of drivers is really bad. So who knows what it didn't like? Could be anything about it, right? And so in this case, yeah, depth component seems like the correct thing to ask for with the GL text image 2D. I don't anticipate there's any problem with the slot value because that's, again, just going to be GL texture 2D, which is what we want. And let me look to see if there's any kind of tutorial version on the internet that would specify this a little bit more. Common mistakes, which is probably what we made. Well, fortunately, it doesn't look like. It does not look like does not look like it. What else we got here? For transfers of depth stencil or depth stencil data, you must use GL depth component, GL stencil text, or GL depth stencil. So in the format parameter, so it's saying that other documentation was wrong, or I don't know, one of these two is wrong. So what you're saying here is GL depth component has to be specified here. For transfers of normal, all right. For transfers of normalized integer flame, you must use the following. For transfer of non-normalized data, blah 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 blah. Okay. Let's see if that's any better. Hey, look, there we go. So, all right, in this case, now that we do not have multi-sampling on, you can see we're back to our situation of everything is kind of z-fighting with itself and going nuts and all this other bad things about which order you drew things in. But we know we can switch to that mode pretty easily, right? Where we can draw without having multi-sampling on. And if we don't have multi-sampling on, then we could, if we want to, have two frame buffers. What we can do is we can draw the whole thing to a frame buffer twice, right? And so I'm trying to think if I need to do anything fancy with depth peeling. Since I can't, I think for depth peeling, I need an additional texture in my shader, right? So, you know, I've got this shader here for the fragment code, and that shader is going to do the depth test automatically, right? But what it's not going to do is it's not going to be able to compare against a range, right? So what I needed to do if I wanted to do depth peeling is I have to have, oops. I have to do something where I say, okay, you know, here was the top level of stuff that got rendered. And so I know what that depth is. And that's in a buffer, right? So I've got this buffer that's the depth image of the screen. The problem is, after I have that depth buffer image and I know where all the depths are, I then still need a Z buffer to figure out what the next layer of stuff is. So I have to compare against the things that I was drawing down here to say I need things that are greater than them or less than them in Z, and I need them to be going upwards, whatever definition we want upwards to be. But then I also need to read from this buffer and say, oh, they also need to be on the other side of this. So I need two depth buffers, right? I need the normal depth buffer that the graphics card would just manage on its own, but then I also need the the depth buffer we record from the previous pass. So I'm pretty sure, unless I'm misremembering how depth peeling is supposed to work, I'm pretty sure what I need to do there is actually sample from an additional texture, right? And that texture has to be a screen space texture. So yeah, I'm pretty sure what that means is that in the second pass through, we kind of need like some pound if code here, right? We need this kind of stuff to happen. And what we need to do is say, well, all right, you know, if we're in the other mode of you know, depth peeling or something, then we need another sampler here. And that sampler is going to be the screen, you know, the depth sampler. And that depth sampler, we got to get, you know, a texture value from it, and that texture value is going to be the depth that we expect to compare against, right? So we need to do something like this. So if we're depth peeling, we need to do a depth, or rather a clip depth or something like this. I don't know what we want to call that, but let's say clip depth is a reasonable name for it. We want to sample that the depth sampler, and we need here to sample this in screen space, right? We need to get like the actual like value of the pixel at the location that we are drawing. And that's a little harder to do than you might think. You would think that that would just be something provided automatically to you. It may be something provided automatically to you in later versions of OpenGL. In this version of the shader language that we're doing, which is kind of an older one to be a little bit more compatible, I'm pretty sure you don't have it. So I think you need to sort of generate it yourself by using the display resolution and the pixel location and doing that divide. So I believe you need to do it that way. I don't know that that's true, so let's take a look. GLSL. Oops, I already had that there. 3.0 quick reference card. Here it comes. So let's take a look here and see what our predefined information is, because that's really what we need, is to know the built-ins that we're going to get. And so you can see in here, like, we get a bunch of stuff. Let me zoom in on that so it's easier to see for the folks at home. So you can see here, like, we're going to get some stuff in the fragment language. You can see that frag chord, point chord, these sorts of things are all specified for us. Frag chord in this case should be the screen space location, I believe. Let me just verify that that's correct. Yeah, window relative coordinates, x, y, z, and 1 over w, values for the fragment. And so in that case, right, we know that, well, let's see here. We need to redeclare with the additional layout qualifier identifier as origin upper left or pixel center integer. But default GLFRs assume a lower left origin for window coordinates and assumes pixel centers are located at half those centers. For example, the XY location 0.5 is returned for the lower leftmost pixel in a window. The origin of GL frag coordinate changed. The values returned can also be shifted by half pixel. and the whole numbers, blah, 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 blah. So there you go, right? That's going to give us just a pixel value. Like I was saying, it's not a value we can use texel-wise to look up. However, not entirely true. Since it is an absolute pixel value, and we know that the viewport that we're rendering to and our texture for depth should be the same, right? We basically want our the window relative coordinate to line up with our texture 1-to-1. Since that's the case, what we can do here also is use a texture sampler that takes the actual integer floating point coordinates, probably, and just be done. So since we don't need to blend, we could be off the hook here and not have to generate these UV coordinates. Because remember, what normally happens is when we do a texel lookup like this, we're specifying floating point values and we're blending because we want that bilinear filtering, like the kind we implement in the software rasterizer. But now I think about it for depth, we're a little bit off the hook here. Normally when you're writing these, you care about actually creating a UV because you want to do sampling a little bit more specific, so you have to back it out. But in this case, I don't think that's the case. So if we want to, we can just do this. Texel fetch is a call that just gets one pixel out, right? It's like I just am getting just the color of a particular fragment, a particular texel in the texture. I'm not going to do any bilinear filtering. And it takes an integer coordinate into the texture. It's just like, here is the pixel value that I want to sample. So I think I can just do that. Because in this case, I don't ever need to engage the bilinear blend at all, so I don't care what the fractional coordinates of this thing might be when looked up into a texture, because the texture is always going to be exactly the right size. It's a very good special case. So what I can do here is say, all right, just pass those through directly, knock yourself out, and here's the clip depth. Okay. So at that point, what I should be able to do is take the z value. Now, I don't know how the z value gets passed down here because I don't remember. And it says here that the frag coord is x, y, z 1/w. I'm hoping that means that the z value is the pre-divided, it's already, a post-divide z value that's actually mapped from -1 to 1. I don't know that that's the case, but I hope that that's the case. Because if that is the case, then I can just compare it directly with the values that are the depth buffer and have a little bit of a party, right? Because everything should line up at that point, and I don't have to think about the spaces that they're in. Now, granted, I don't really know how the depth buffer is going to come in this case. Again, we have to check when we set it to depth component 24, does it come out as a -1 to 1 value, or does it come out as a 0 to 1 value, which is not what I would want? And I don't know. But we'll have to verify that and go from there. But anyway, so in this case, I've got clip depth. It comes out. All I really need to do now is just introduce a way to discard the texture, a way to discard the pixel right. And so all I want to do is say, OK, if the frag z is closer to me, right, and because it's going to be a less, if the fragment z is less than the depth value, that means this is in front of it, and I wouldn't want it, right? So in this case, I want the frag z to be greater. I want the frag to be behind, I believe, in this case. So in the case where it's behind, then we'll go ahead and do. And you know what? I could make this easier on ourselves and say, all right, actually, let's do it the other way. If it's if the fragment z value is either at this depth or behind or closer to us, throw it out. And then continue on. Right? And that way it's a nice little self-contained thing up here at the top. I don't know what this is supposed to be. Let's get rid of that. And so that would allow us to fetch from a depth sampler at the location we were at as another check to see whether or not we pass a z-test, in addition to the z-test we already have to pass about being the closest thing to the viewer for the stuff that's not being peeled away. So yeah. So this, again, I can just keep going like this to get us a little closer to where we need to be, and next weekend we can focus on getting the depth peeling working. So let's take a look here at what I would want to do. So because I would now have two different shaders that I might want to run, we have to extend our notion a little bit of how we're actually keeping these shaders set up, right? Because we kind of have all this junk sitting in here, and we don't really have any good way of managing it. So we kind of want something a little bit more, structured. Like we probably want to say, like, okay, here's all the information we were using for this program. Let's put it all into some kind of a struct, like so. So that then we can just say, like, okay, here's our OpenGL program, and it's got the program handle, and then it's got all this other stuff that we need to set in there, right? And in this case, we also have additional things we might want to set, which is like the depth sampler ID. But otherwise, it's pretty much the same in both cases. So then we could say, like, all right, we've got two OpenGL programs. We've got the z-bias pass 0 and z-bias pass 1, because it'd be the two passes, the first pass and the second path. Or z-bias no depth peel and z-bias depth peel might be the better way to name them. Pass 0, pass 1. And in this case, now what we want to do is we want to compile these in both ways. So what you can see here is I actually set us up to be able to do this in not too annoying of a fashion. You can see that we've got the format string that gets sort of printed differently here. It's not too hard for us to compile this shader multiple times and do all this stuff by just pulling it out into a little function and calling it twice, which is kind of handy, right? So I can do something here where I say, okay, compile z-bias program, and we'll just take an OpenGL program as the target to fill out. And then what we do is we just clip all this stuff out here. And put it in here. And then what we could do is say, all right, all of this stuff that we were doing before that's off of the OpenGL pointer is now just going to be off of the result pointer. And in theory, we should have a couple of the things that we need to do here. I kind of wanted to focus on this part first. There we go. So we need to know a little bit more about the read and write sRGB stuff, in this case. And then we need to change the names of some of these saucy gentlemen down here. Let's see what we've got for that. And this all the program handle. I'm going to go ahead and put the program handle into something temporary so we don't have to do it every time. So I'm just going to go like prog equals create program. And then I can say something like this. And now that should be a little bit clearer. And the only thing that we're missing is these two settings, the shader sim text write. And those were not on the OpenGL, but I'm going to put those on the OpenGL because those are actually things we might want to know often, right? So I'm just going to stick those on there. So that we can always access them. Because those are just global things that are like this graphics card either can do it or it can't, and everyone wants to know that. So then all we have to do now is say, well, all right, to restore the functionality of this this thing here, I should probably go ahead and make setting up the program in this way just be something that you can use in a nice sort of callable fashion. So I can do something like this where I say, begin program, or begin program usage, or begin use program begin, I don't know, use program end, something like that. And so then in here I can say like, okay, let's go ahead and pull that out. By the way, where is my little, why did my little head blocker go away? Does anyone know where that went? Nobody knows. Anyway, let's just pull this stuff out here. All of this stuff. I guess technically the vertex array stuff. I don't know about the, I don't know if the buffer data thing should come out into that or not. That's harder to say. I'm going to try it like this for now. And if that turns out to be a huge, tiny mistake, then we'll kind of go from, we'll pull it back. We'll pull it on back. But if it turns out to be not as huge of a tiny mistake, then we'll be okay. So we'll do use program begin, then we'll use program end here, and just have that do what that does. There we go. Okay, and so in this case, what we want to do is say, all right, let's use the z-bias program, with no depth peel. And so in both of these cases, like we're just going to pass the program. And then in all these cases, I think we're just going to go ahead and say that OpenGL dot becomes prog arrow. And I think that's really all there is to it. So this needs to get the values from somewhere, which is just the setup data, and that's pretty easy for me to pass in, so I think I just will. That is just this. So let's take a look if me doing that. And I don't know that vertex base doesn't get used here. So I think vertex base is really wants to be left out here. I don't know if it gets used here either. It doesn't. So that's really just dead code. Probably there from when we were pushing them on in the other way. Looks like that's about all there is to that. And in theory now, we have sort of abstracted ourselves away into a place where we can call multiple programs. Now, of course, I have to actually debug it, but other than that, hopefully we're okay. So let's see what message says. Uniform says failed because the operation requires a currently active program object. You know what? One of those things that probably helps here is if I actually went ahead and compiled the program. We're not actually calling that at startup, so hey, there's no program at all, in fact. But that's okay. So let's go ahead and say compile z-bias program, and let's say that into the z-bias no depth peel. Furthermore, let me compile one into z-bias depth peel, and in this case, I'll just say, well, hey, there's no z-bias here, there is z-bias here, something like this. And then what we can do is say, that gets passed in. And this will literally be, 1 or a 0 based on depth peel, which I think we can really just do that. I forget what I called that defined depth peeling. Maybe I'll just make it depth peel. All right. So now in theory that should compile two programs for us, one of which has the depth peeling in it and one of which doesn't. Again, that's just in theory. Looks like we've got a compile error here, probably on the depth peel code. No matching overlay function texture fetch. Let's see what the problem is here. So first of all, I do need to do frags equals gl fragchord.z, and hopefully that's in the right space. What I don't know is whether that's complaining about the fact that this is not an IVEC, because I don't know. I think gl fragchord, yeah, is actually a vec4. So I actually need to convert that to an IVEC, and I don't really know exactly how that's supposed to get done. I guess I could do this, which I think will truncate it to an integer, but it should already be an integer because we're not multi-sampling anymore. So in theory, that should have done it. But I don't know if that's what it was actually complaining about or not, because it's not very specific. No matching overlay function called for texture fetch. So let's take a look at what texture fetch needs to know. There's probably a couple other things there. Let me just take a look at what texture fetch actually wants. So it needs the LOD to sample from as well, so MIP mapping. It's which MIP map to sample from. And we're not going to have any of that for the depth buffer. It's 1-to-1. So I just needed a 0 in there. That might be all that was worried about. I don't know. We'll find out. Still doesn't like that. So I don't know what it's complaining about. We are passing a sampler. We're passing an IVEC2 now. And we're passing a 0. So, oh, how about I name the function properly? That's a good start. One might think. Cannot convert from 4-component vector of float to high p float. I don't know what that is. What is a high p float? I really don't know what that means. High precision float? Maybe? I do not know. But a 4-component vector of float to high p float is not something I know what that error means. So, oh, well, this is pretty obvious here. Sorry. That's just it trying to tell me that, hey, the texel fetch, it doesn't know that I'm going to be binding a texture here that only has one component in it, right? Like, I'm only binding a depth texture, so there isn't an RGBA to it, there's just an R. But texel fetch is defined as returning an RGBA, so I have to tell it I only want the R channel, right? Because I'm only taking just that one value from it. So, yeah, what are you going to do? All right, so now I think we're at the point where I should probably stop for the day. We are now able to run the depth peel or the regular version. And so now what we need to do in order, and you know, I can leave us running in a more reasonable state, I suppose, as well by just taking the renderer here in OpenGL and saying, well, yeah, you know, let's still keep that multi-sampling for now, friends, because we need it. So we'll just leave it like that for now. I'll go ahead to the Q&A. There we go. And next weekend we'll get the depth peeling working, because that, you know, it's going to be a bit of just a graphics debugging kind of a situation. Gary Johansson asks, while we wait for other questions, have you had a good experience with GDB? Not really. I guess what I would say about GDB, I think, is a pretty good debugger from what I've experienced with it in terms of actually having all the features that I want. It has like a lot more features than like Visual C++'s debugger does, the one that I'm using on stream, right? The problem is it's just extremely cumbersome to actually use. And so the human factors involved means that it takes way more time to debug the common cases, where you just want to have basically a heads-up display of showing me some variables while I'm stepping through the code. That is just so bad on GCC comparatively that it makes the everyday debugging tasks a pain in the butt. When you actually need to do a very complex debugging task, GDB is actually usually better. But that's not the majority of the kind of times that I use the debugger. Like usually I'm just using the debugger to quickly see a simple error. I'm not trying to do stuff like, oh, set a memory breakpoint and record once you hit that memory breakpoint and then stop when you hit a crash and go back to the memory breakpoint and let me step forward to see where the, like, you know, it has all these features. But the problem is debugging, I mean, the way you think about it is a debugger is just there to save you time. Without a debugger, we could still do it. You know, people develop software without debuggers even today. They develop software all the time without debuggers in the old days when they didn't have debuggers. So a debugger is just, the only point of a debugger is to save you time. It's to take a bug that would have taken you 2-3 hours to find and make it take 10 minutes to find. Take a bug that would have taken 30 minutes to find, make it take 5 seconds to find, right? It's just trying to save you time. And GDB doesn't save you time because it's too cumbersome. Like, the amount of fussing and the degree to which it does not clearly present the information in quick-to-view ways is really its problem. And for whatever reason, I think some people tried to explain why this was at one point. It had to do with how you conduit the data back and forth with GDB. When people make front ends to GDB, they're always like very slow and clunky and kind of buggy and stuff. And so I've never really used a front end to GDB that was able to, you know, clean that away. But I don't think, you know, I strongly suspect that all the features for GDB are there. I don't know if the performance is there. It may be that it's just too slow, and that's a problem as well. Because again, the point of debugger is to save you time. If it's too slow, that's not acceptable, right? So I don't know. So it's really hard to say, but what I would say is no, generally I've not had good experience with GDB. I have to use it sometimes on platforms, like when you're on Linux, you kind of have to use it. You're either using GDB or you're using a front end of GDB, one or the other. But I have not had positive experiences with it. I don't like it. And it is almost 100% human factors related. It's never, you know, I've never had the experience of I need GDB to do something and it can't do it. That's never the case. It's always that the thing I want to do takes too long, it's displayed poorly, it's not displayed contextualized properly, it's too slow to step or to do this. You know, it's always human factors, not feature. That's been my experience anyway. I can't think of a feature, for example, that Visual Studio has that GCC doesn't also have, I mean, GDB doesn't also have. Uplink coder, how to stabilize the volume outlines. You're just talking about the fact that they're, because of the Z fighting or whatever. So one of the things that we have an issue with, right, is anytime we're drawing debug stuff, it might necessarily like overlap exactly with something in the world. And so you end up with Z fighting, like in this case, where the Z values happen to be right on the edge of this thing. And whether or not it gets drawn first or second determines what we would see there. And you know, it may not be pretty. I don't know what the best way to remove that right now would be, because I'm not really thinking about it. But obviously we have some tools at our disposal. Since we have Z-bias as an option, one thing you could imagine is, you know, when we do push volume outline and we draw all this stuff here, what we could do is say that our line segments, since they're debug-based information, we could throw a z-bias in here, right? So instead of having all of these things be at 0, they could all have a little bit of z-bias, which allows us to sort of like prefer that our debug stuff gets moved a little bit forwards. So we could say something like, why don't you just give all of our debug line segments just a little bit forward, just push them a little bit forward so that they don't z-fight. And I don't know if that's what you were asking, but now you'll notice that the z-fighting is gone, right? Because we push them forward. Does that answer the question? There's other ways. You can be more analytical about that. And if like what you really cared about a ton in a game was like getting lines and solids that happen to go along in the same places to render well or stably, there's certainly more you could do analysis-wise. But for our purposes, I mean, assuming that's fine. I don't know. Akoto87, to follow the rule of writing the usage code first, don't believe that the product is at a point where it is better to advance in the game now, and when the game need for more engine features, then go and implement it. Sort of yes and sort of no. I mean, generally speaking, one of the problems that we have on Handmade Hero is I don't really have any... we sort of have this problem of typically you would have a game designer, and the game designer has designs that you would implement or something. And you can do more of that as you go. You can sort of say like, well, all right, let me implement more of the game and then go back and implement more of the engine and so on. In our case, we don't really have that because this is not a game design stream. And so to a certain extent, I don't really spend a whole lot of time thinking about the game itself. I more just think about the game engine and like, I would like to add this feature, I'd like to add that feature, and I try to do those in a way that makes sure that we write the usage code or whatever is the most sensible thing to write. I try to let it go from there. But I don't really have a strong opinion about the game design side of that because I don't really do that kind of thing. And so in this case, no, not really. Like, I don't really feel like that's anything in particular that I want to do. If other people who are more about, I have a specific game design and I just want to make the game that goes with that game design, the engine that goes for that game design, you could definitely take that approach and it'd be very reasonable, right? Because it avoids you doing things that maybe you don't really need to do because, maybe you find out that they're not very necessary for the way the design evolved. But again, that's really more for, I'm an engine programmer, not a game designer. And so going past the engine part of things just puts me into territory where I'm just like, I don't know, I don't care, right? It's like, I have no opinion about how this should be. I could just do it the way the engine did it, and that's the game design, right? So in order to really start having the game design per se dictate backwards how the engine works, you have to be more of a game designer and know more about how that should look. For all I know, like having pretty multi-level fading will be something I just make happen in the game design because like I just want this look. And that is not a game design decision, right? That's not something a game designer probably would do. I don't know, I'm not one. But if I go, oh, there's a cool effect there, I'm like, well, guess what? Our game's going to have multiple levels. Even if it's stupid and the game is not fun as a result, I'm just like, I'm making an engine, not a game, because I don't know how to make a game, right? I'm not a game designer. And so that's really mostly why I don't spend any time thinking about the game part of things, really. I just know, okay, here's the basics. There has to be a thing that moves around on a grid. That's what the engine has to do, so do it. And then from there, I'll just be like, well, the game is whatever the game is from there, and the game, exists within that engine. And that's all I can really say. I don't have really anything else I can offer in the way of advice there. I think someone like John, so if you can, I don't know, John Blow's streams tend not to really show him working on a game per se, because he mostly does like the compiler stuff now and some other things like that. but I guess what I would say is he is the kind of person who could show how to do that reverse process properly, because when he does game development, he definitely does it the way you're suggesting, which is he works on the design of the game in the engine and adds the features to the engine as he decides he needs them for that game. And so he would be able to do a really good job showing how to make that work. But that's outside of my area of expertise. I don't do that. Okay. Uplink coder clarification: what to do when the angles are too close together? Oh, for the volumes. So again, I think drawing cylinders or something with end caps might be the only way to really get them more stable than they are now, because again, we would need something to happen when you were hitting them edge on. Since I don't care about that because they're not in the end product of the game, they're fine for me right now. Like, I'm totally happy with where they are right now. Justin Meyer, the debug text is drawing behind the sprites, by the way. Yes, that's true. I don't necessarily know what we're setting the Z values for on those. But one thing that I would point out is we really should just draw those in a separate pass. Like, if we wanted to, we could do something like this. I don't really know what this would be exactly, but, we would say in here when we come through, case render group entry type, render entry depth clear, and then I would just say gl clear, gl depth buffer bit. And so the depth buffer could get cleared at a certain point, and then at that point, we would basically say, okay, we're done drawing the world, clear the depth buffer, because when we're going to draw the debug text, we want to overlay it on top. We don't want the depth buffers interfering with each other, right? And that would be all we would need to do there. So let's go ahead and specify. Well, the header already gets advanced, so that's really all we need. There isn't a structure for that, although I guess we could make one. But so then all you would do is you would say in here when we do push, where is it? Push. So here's our push render element, and our push render element we could just have a push depth clear. And it would literally just call this and say, I need a clear. And I want it to push on a render element with 0 size. And this type, right? And so then anytime we wanted to, like before we do the debug stuff, on here we could just say, well, when the debug stuff starts going, before it renders anything else, let's just clear everything out, right? So let's just say, like, okay, in the render group here, we set up the camera transform for the debug group, and then we just want it to clear everything out of the depth buffer so that it'll draw it on top. And then you can kind of see that just allows all of this stuff to always be on top no matter what. And that's probably what we want to do, because that way we don't have to save a Z buffer, Z buffer space for anything or whatever, right? I don't know if that makes sense. Yeah. So let's see here. Hello, do you have any idea when engine layer will be finished and you move to just gameplay programming? Not really, but I don't think there's very much left, so we'll probably be doing mostly gameplay programming from, probably August on. I don't know that there's going to be much to do. We probably have a couple things in the engine that'll have to get upgraded. Like we never really did the collision detector stuff, so and then we probably need to do something about like the for queries, closeness queries. Those will get too slow when we have more entities in the game. So some things like that. But mostly the rest of the stuff will just be gameplay because we kind of haven't. I don't know that there's really much else. So world generation and that stuff I'm including in gameplay programming. But world generation is a big one. So I don't know if you don't consider that gameplay programming, but I'm assuming that's gameplay programming because it's specific to the game. Jezzy23, I'm not sure if the profiler shows some insightful information about CPU cache hit or miss rates. How might you implement something like that? I don't think you can. If I remember correctly, the only thing that you can do is actually install, if you're willing to install some specific Intel drivers, I want to say you can get it. But I'm pretty sure that on x64, normally the Windows, they turn off the ability to access the cache miss information because I think of a security concern, I want to say. So you can't actually get that just on a vanilla build like we have. It is just a feature of the CPU. The CPU has performance countering information that you can modify. It might not be for security. It might just be because, hey, it can't be save and restored across apps. Might be the real reason. Because, the CPU can only have one set of counters, I think. It doesn't keep per thread counters. Although you could just save and restore them. It may just be because the OS doesn't save them. I don't know. I'm totally speculating here. I don't remember. All I can say is on other platforms, so let's say you're on a dedicated machine like Linux machine or something, and you're just doing kernel stuff or whatever, you can just get that. You can just ask. You can just ask the CPU. It has counters. You can say, I want to know all the level 2 cache misses, and it'll just count them for you. And so you can go look up information of that on the web about how to implement stuff like that. It's definitely possible. And it's just CPU, and it's just direct CPU instructions that can do it. The problem on Windows is that as far as I remember, you can't get that information without installing a special Intel driver or being you have to be a device driver basically so that you can do that stuff at kernel mode. Because I'm pretty sure user mode's not allowed to get it, but don't quote me on that. There may also be a way to get it with like event tracing for Windows or some other huge heinous API that you don't want to touch, but I don't really know because you don't want to touch it. But what I can tell you is that information is very easy to come by on the CPU. So if that's the sort of thing you really care about, you can either install drivers that will let you query it on Windows, or you can run on a different operating system and get it. Can the depth buffer contain infinity as a floating point value? As far as I know, yes, but only if it's actually a floating point depth buffer. So one thing that you have to remember is the depth buffer has to be encoded in some way, just like a regular texture. So one way to encode the depth buffer is to just have it be a 32-bit per texel depth buffer, and that can actually store a floating point value if you want. You can use depth component 32F, and then it's actually a floating point value with the mantissa and the exponent, just like we normally think of one. And that probably can store infinity just fine because all it's doing is storing a float. I don't actually know that that's true because I've never tried it, and there may be restrictions on the hardware as to what can pass through where and so on, so I don't know, maybe there's a caveat there. But what I can tell you is that infinity would not be easy to store in a case where you weren't using floating points. So say you use depth component 24, maybe it's not floating point, it's actually a fixed point, 24-bit encoded fixed point. That wouldn't be able to store infinity in any particular way because all of the values are actually used. So there isn't a way to make a special value infinity. Now you could make your own special value for infinity by doing specific stuff to try and make that happen, but it's complicated, right? So you have to understand, I don't know the exact answer to your question because I've never thought or tried that before. But what I can say is that while it certainly seems like it should be plausible in the case where you have a 32-bit floating point depth buffer, in all the other cases, it sounds a little bit trickier. All right, I think we're done. I see no more Q colons, except for what part of game programming do you enjoy the most? Engine, gameplay, etc. Definitely engine. I don't like gameplay programming. That's why I try not to do it on Handmade Hero. All right, let's close things down. Thank you, everyone, for joining me for an episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along at home, you can always go to handmadehero.org and pre-order the game. It comes with all the source code, so you can play around with it on your own. We also have a forum site you can go to if you want to ask questions, a Patreon page you can go to if you want to support the video series, a schedule bot that tweets a schedule at you if you'd like to know when we're going to be live, and also an episode guide if there's old episodes you want to catch up on, stuff we covered that you would like to see. That's it for today. I kind of like this depth peeling idea. I've never really thought about it before. I'm interested to try it. So we'll be back next weekend to play around with that and hopefully see if it is a useful concept. I think it might be. That's about it. I hope to see you back for that. Have a fun week programming till then, and I'll see you on the internet. Take it easy, everybody.